Wannan shine darasinmu na ƙarshe a cikin program ɗinmu na Basic Electronics, kuma za mu yi magana ne akan diode. Menene diode? Kuma ya diode yake aiki, da kuma ire-iren diode. To shi dai diode wani component ne wanda ake amfani da shi a cikin kayan wuta. Kuma na farko yana bari wuta ta wuce a direction wuri ɗaya, kuma yana hana dawowan wuta baya. Shi dai diode an yi shi da semiconductor material ne, kaman silicon, germanium da kuma selenium, wanda ainihin tsohon diode wanda aka yi amfani da shi da selenium da germanium ne, sai kuma yanzu aka fi yawan amfani da silicon. Shi dai diode yana da maki a jikin shi, sannan kuma yana da ƙafa guda biyu. Daga cikin ire-iren diode akwai light emitting diode, shi kuma diode ne wanda yake fidda wuta a jikin shi, kaman globe haka yake. Akwai kuma photo diode, shi kuma light sensitive device ne, wanda shi kuma da zarar ya ji hasken rana ke detecting. Akwai kuma zener diode, shi kuma yana regulating ɗin wuta ne, yana bari wani percentage na wuta ya wuce, kada wuta ta yi yawa kuma kada wuta ta ƙona abin da ake aiki da shi. Varicap diode, akwai kuma shocky diode. Shi dai power diode ana amfani da shi a wurin rectification na wuta, musamman a maida AC ya koma DC, musamman yawancin kayan wuta da muke amfani da su. Idan wuta ta fito daga main source ɗinta tana alternating current kenan, tana fluctuating, ba ta tsayawa wuri ɗaya. So in aka yi amfani da power diode, ko dai full wave ko kuma half wave rectification, so zai tace wannan wutar da take rawa sai ya bar direct current ya wuce. Kuma ana amfani da diode a wurin signal, wurin tace signal, wani part na signal inda ba a so a bar wani signal kuma ya wuce. Diode yana da number a jikinsa, wanda kowanne number ya danganta daga yanayin wutan da take saki da kuma yanayin inda ake amfani da shi. Yanda diode yake aiki shine, yana da ƙafa guda biyu, yana da positive, yana da kuma negative. So idan ta positive ka sa wuta ta bi ta wuce, za ta bi direct ta cikin diode ɗin ta wuce. Amma idan kuma inda positive ɗin yake sai ka sa negative, to wutan ba za ta wuce ba, ma'ana zai yi blocking ɗin shi. Domin shi a tunanin shi shine wani short circuit ne ya faru, so wutan za ta iya shiga cikin component ta yi ɓanna. To shi ma diode yana da wasu percentage na wuta wanda yake riƙewa kafin ya saki wutan ta wuce. So wannan ana kiran shi da threshold voltage. Wato kaman wani tsani ne wanda idan wutan ta zo, idan bata haura tsanin ba, wutan ba za ta iya wucewa ba. Mafi yawancin threshold ɗin su bai wuce 0.4, 0.7. So ta inda za ka gane alamun inda positive yake da kuma inda negative yake. So inda negative yake za ka ga wani ɗan maki a jikin shi zagaye da shi. So daidai ƙarshen da ke da wannan makin shine negative. Daidai inda kuma bai da wannan makin ɗin shine positive. Saboda haka idan kana so wuta ta wuce ta cikin diode ɗinka, sai dai idan ta taso in ka sa positive ta bi ta cikin positive sannan ta wuce ta negative, ko kuma ka sa negative ta biyo ta wurin negative ta wuce ta positive. Shi ma diode yana da PN junction kamar yadda transistor yake da shi, sai dai shi na diode P and N guda biyu ne, da positive da negative. Nan positive nan holes suke, shi kuma negative nan electron yake. Saɓanin transistor wanda yake da guda uku, ko PNP ko NPN, wanda ana iya kunna shi ta hanyar gate. Shi kuma diode bai da gate. Gate ɗin shi shine ka sa wutan ta bi ta wuce direct. Idan kuma ka canza polarity, so wutan ba za ta wuce ba. Shi ma semiconductor ne, aka ƙara mai wasu element wato doping, wanda aka sarrafa shi ya rinƙa fidda electrons da yawa. Shi ma diode kamar sauran electronic component ne wanda aka yi su da semiconductor material, ba su son interference na signal ko electronic interference, ko dai a form ɗin shock, spark ko short circuit haka. Yanzu za mu je mu kalli wani video mu ga yadda diode yake aiki. Sai kuma certificate, ku duba a cikin description ko kuma comment section, za ku ga link wanda zai kai ku, za ku cika form ɗin da za ku anshi certificate, sai ka rubuta details ɗinka da sunanka yadda kake so ya fito a cikin certificate ɗin.
So what is a diode? A diode looks something like this, and it comes in different sizes. They typically have a black cylindrical body that has a stripe at one end, as well as some leads coming out to allow us to connect it into a circuit. This end is known as the anode, and this end is the cathode, but we're going to see what that means later on in this video. You can also get other forms such as the Zener diode, or an LED, which is a light emitting diode, but we're not going to cover those in this video. A diode allows current to flow in only one direction in a circuit. If we imagine a water pipe with a swing valve installed, as water flows through the pipe, it will push open the swing gate and continue to flow through. However, if the water changes direction, the water will push the gate shut and this will prevent it from flowing. Therefore, water can only flow in one direction. This is very similar to a diode. We use them to control the direction of current in a circuit. Now I've animated this video using electron flow, which is where the electrons flow from the negative to the positive. However, you might be used to seeing conventional flow, which is traditional in electronics engineering, and this is where the electrons flow from the positive to the negative. Electron flow is what's actually occurring, but you might come across conventional current still, as these explanations are easier to understand. Just be aware of the two and which one we're using. So if we connect a diode into a simple LED circuit like this one, we see that the LED will only turn on when the diode is installed the correct way. And that's because it allows current to flow in only one direction. So depending on which way the diode is installed, this will act as either a conductor or an insulator. In order for the diode to act as a conductor, the stripe end is connected to the negative and the black end is connected to the positive. This allows current to flow. We call this the forward bias. If we flip the diode, it will act as an insulator and the current can't flow, and we call this the reverse bias. So how does the diode work? As you may know, electricity is the flow of free electrons between atoms. We use copper wires because copper has a lot of free electrons, which makes it very easy to pass electricity through. We use rubber to insulate the copper wires and keep us safe because rubber is an insulator, which means its electrons are held very tightly and they can't therefore move between other atoms. If we look at the basic model of an atom for a metal conductor, we have the nucleus at the center, and this is surrounded by a number of orbital shells which hold the electrons. Each shell holds a maximum number of electrons, and an electron has to have a certain amount of energy to be accepted into each shell. The electrons located farthest away from the nucleus hold the most energy. The outermost shell is known as the valence shell, and a conductor has between 1 and 3 electrons in its valence shell. The electrons are held in place by the nucleus, but there's another shell known as the conduction band. If an electron can reach this, then it can break free from the atom and move to another. With a metal atom such as copper, the conduction band and the valence shell overlap, so it's very easy for the electron to move. With an insulator, the outermost shell is packed. There's very little to no room for an electron to join. The nucleus has a tight grip on the electrons and the conduction band is far away, so the electrons can't reach this to escape. Therefore, electricity cannot flow through this material. However, there's another material known as a semiconductor. Silicon is an example of a semiconductor. With this material, there's one too many electrons in the outermost shell for it to be a conductor, so it acts as an insulator. But as the conduction band is quite close, if we provide some external energy, some electrons will gain enough energy to make the jump from the valence and into the conduction band to become free. Therefore, this material can act as both an insulator and a conductor. Pure silicon has almost no free electrons, so what engineers do is dope the silicon with a small amount of another material to change the electrical properties. We call this p-type and n-type doping. We combine these doped materials to form the diode. So inside the diode, we have the two leads, the anode and the cathode, which connect to some thin plates. And then between these plates, there is a layer of p-type doped silicon on the anode side, and the layer of n-type doped silicon on the cathode side. The whole thing is enclosed in a resin to insulate and protect the materials. Let's imagine the material hasn't been doped yet, so it's just pure silicon inside. Each silicon atom is surrounded by 4 other silicon atoms. Each atom wants 8 electrons in its valence shell, but the silicon atoms only have 4 electrons in their valence shell, so they sneakily share an electron with their neighbouring atom to get the 8 they desire. This is known as covalent bonding. When we add in the n-type material such as phosphorus, it will take the position of some of the silicon atoms. The phosphorus atom has 5 electrons in its valence shell, so as the silicon atoms are sharing electrons to get their desired 8, they don't need this extra one, so there's now extra electrons in the material and these are therefore free to move. With p-type doping, we add in a material such as aluminium or aluminum. This atom has only 3 electrons in its valence shell, so it can't provide its 4 neighbours with an electron to share, so one of them will have to go without. There is therefore a hole created where an electron can sit and occupy. So we now have two doped pieces of silicon, one with too many electrons and one with not enough electrons. The two materials join to form a p-n junction. At this junction, we get what's known as a depletion region. In this region, some of the excess electrons from the n-type side will move over to occupy the holes in the p-type side. This migration will form a barrier with a buildup of electrons and holes on opposite sides. The electrons are negatively charged and the holes are considered therefore positively charged. So the buildup causes a slightly negatively charged region and a slightly positively charged region. This creates an electric field and prevents more electrons from moving across. The potential difference across this region is about 0.7 volts in typical diodes. When we connect a voltage source across the diode, with the anode, the p-type, connected to the positive and the cathode, n-type, connected to the negative, this will create a forward bias and allow the current to flow. The voltage source has to be greater than the 0.7 volt barrier, otherwise the electrons can't make the jump. When we reverse the power supply so that the positive is connected to the n-type cathode and the negative is connected to the p-type anode, the holes are pulled towards the negative and the electrons are pulled towards the positive, and this causes the barrier to expand. Therefore, the diode acts as an insulator to prevent the flow of current. Diodes are represented in engineering drawings with symbols like these. The stripe on the body is indicated with a vertical line on the symbol, and the arrow points in the direction of conventional current. When we look at a diode, we see these numbers and letters on the body. These identify the diode so you can find the technical details online. The diode will have an IV diagram that looks something like this. This diagram plots the current and the voltage characteristics and forms this curved line. This side is how it should perform when acting as a conductor, and this side when acting as an insulator. Into a simple LED circuit mounted in a breadboard, I get a voltage drop reading of 0.71 volts. So why do we use them? As mentioned, we use diodes to control the direction of current flow in a circuit. That's useful, for example, to protect our circuit if the power supply was connected back to front. The diode can block the current and keep our components safe. We can also use them to convert alternating current into direct current. As you might know, AC or alternating current moves electrons forwards and backwards, creating a sine wave with a positive and a negative half. But DC or direct current moves electrons in just one direction, which gives us a flat line in the positive region. If we connect the primary side of a transformer to an AC supply and then connect the secondary side to a single diode, the diode would only allow half the wave to pass, and it would block the current in the opposite direction. So the secondary side of the circuit experiences only the positive half of the cycle, so it's therefore now a very rough DC circuit, although the current pulsates, but we can improve this. One way to do that is if we connected 4 diodes to the secondary side. We create a full wave rectifier. The diodes control which path the alternating current can flow along by blocking or allowing it to pass. As we just saw, the diodes allow the positive half of the sine wave to pass, but this time the negative half is also allowed to pass, although this has now been inverted to turn it into a positive half also. This gives us a better DC supply because the pulsating has greatly reduced. But we can still improve this further. We simply add in some capacitors to smooth out the ripple and eventually get it to a smooth line closely mimicking a DC supply.